So hello everyone, welcome to our StereoChemistry lecture, and it is a lecture 9. So basically in this particular lecture we are talking about the some unusual chiral compound. Like in previous lecture we are talking about that a chiral center based chiral compound, like that particular compound which is shown the chiral must have a chiral center. But here in this particular lecture we are talking about some different kind of chirality where there is no chiral center present rather than a chiral axis present, and this type of molecule we are calling about the axial chirality. Okay, so what is axial chirality? So first of all, let us talk about the definition. Okay, so axial chirality arises when molecules have a chiral axis rather than a chiral center. This type of chirality is common in certain type of organic molecules such as biaryls, alene, and some cumulenes, where restricted rotation around a bond leads to distinct spatial arrangement. So here in this particular compound, you can easily find that the particular marked yellow line is nothing but a chiral axis. Now, why the chiral axis? Because it contains different groups, whereas these two groups are present in the plane of paper, where these two groups are present below or above the plane of the paper. Okay, and this type of system doesn't have any plane of symmetry, and we already know that if any compound become a chiral, it doesn't have any plane of symmetry. So this type of molecule where the chiral axis is present, in this type of molecule there is no plane of symmetry present. That means it is a chiral molecule. Now, interesting thing is, like in the chirality part, we have actually talking about that whenever the particular chiral center contains four different groups. But here you can find that this A and this A are the similar groups. Okay, but B A not equal to B, but B and B are the similar groups. So two different group is there. So the rule here says that in any periphery there should be different groups present. Like A and B should be different. Like if there is also A group is present and here is also A group present, then there a plane of symmetry will be there, and which actually doesn't decrease the concept of chiral axis, and it become a achiral molecule. If this both are A, then it become achiral because there is a plane of symmetry present in that particular part. Now here I want to tell you about something about cumulene system. Like this type of system is called a cumulene or alene systems. So cumulene system is a type of organic compounds which consecutive double bonds such as butatriene present. Cumulene can exhibit unique electronic properties and geometries. So you must be wondering that why in this particular system these two groups are in plane and these two groups are out of the plane. So by using cumulene strategy we can easily describe here. So here you can see that in orbital diagram, this we can imagine is the py orbital or pi orbital, and this is the pz pi orbital. Now here in this particular carbon, the py is overlapping with this particular carbon to make this pi bond. Okay, so these two pi orbital, that is we are assuming this is a py orbital. This py orbital are actually make this particular pi bond with this, and since the py orbital is occupied here to maintain the pi, determine the pi bond, so it will be a pz orbital, or you can say vice versa, that this is pz and this is py. It is completely upon you, but the fact is that py and pz orbital are perpendicular to each other, and this pz orbital are actually responsible to make this particular pi bond. Okay, so what happened that these two particular pi bonds are perpendicular to each other. Okay, and that's why these two groups are become not in the plane. But if there is, here is the even number of double bond present, that's why this particular scenario happened. But here if the odd number of double bond present, so what happened that here the py are responsible to make the particular group pi orbitals. Here the pz's are responsible to make this pi orbital, and again the py, vacant py are actually responsible to this particular. So what happened? The particular structure is something like this, then this 90-degree, and again attain this particular structure. So what happened? These two particular peripheral group now become in the plane of paper. And since it is the plane of paper, the peripheral, that means the POS is there. So this particular molecules are achiral and this particular molecule is chiral. Okay, so here it is clearly written that in a cumulenes system, if successive double bond number is even, that means here, then the molecule become non-planar and that means it will show the axial chirality. But if the successive double bond number is odd, then the molecule becomes planar and it will become not a chiral compound. This is a achiral compound. Okay, achiral. Now, here another interesting thing is observed that is called atropisomerism. Atropisomerism is a type of stereoisomer that is resulting from restricted rotation around in a single bond. This particular thing is specially observed in the biaryl compound. Like here in this particular example, there is a 2-phenyl group that is joined in this particular CC carbon bond. Okay. Now here what happened that this since these particular groups are hydrogen, so the steric hindrance is very less here. So this particular group present in a planar form. But when we actually remove this particular H group and put a bulky group here, then what happened? This particular interaction or steric interaction becomes much more prominent so that this particular bond is rotate up and it become this type of structure or the perpendicular structure to eliminate the steric hindrance because of the ortho substituent groups. Okay, and this type of isomerism is called atropisomerism. Like here it is clearly written that when it is a unsubstituted biphenyls, that is a planar because of the lesser steric hindrance between the two hydrogen molecules. Whenever the ortho group has been changed from hydrogen to a bulky group, that is here is the NH2 group and the COOH group, then to eliminate the steric repulsion, this particular CC bond has been rotated such a way that two rings are become perpendicular to each other, resulting this type of geometry, and this type of isomerism is called atropisomerism. Okay, I hope this will be clear for you. Now let us talking about some different kind of chirality, is the planar chirality and helical chirality. So planar chirality, it is a involve a plane of asymmetry offsets in the molecule with restricted rotation around a bond. Okay, so particular in this particular example, you can see that this type of compound are become so rigid, and since and also it contains a asymmetric plane. Like there is a no plane of POS present here because this particular group is restricted, and due to the restriction of this particular molecules, this compound become a chiral molecule and it will be classified as a planar chirality because a molecule contains in plane but still it is have a plane of asymmetry. Okay, not plane of symmetry present here. And helical chirality suggests involves a helical structure where the chirality arises from the direction of the spiral, such as DNA or helical polymers. So here in this particular group, you can find that this type of compound are the initial phenyl rings are out of the plane, and as the helicity is increasing in that particular group, this particular group become above the plane, and this is due to the because of eliminating the steric hindrance, and this type of compound becomes chiral, and this type of compound are being classified as helical chirality. Now if the rotation from the lower or the below the plane of paper to above the plane of paper is going for a clockwise rotation, then it is classified as a M helicity. Whereas if the rotation from the below the plane group to above the plane group is anti-clockwise rotation, then it is classified or determined as a p helicity rotation. It will be very important because sometimes CSIR net asks this type of questions. Okay, now we are talking about again axial chirality, like that I already discussed about cumulating system, that aliens with even number of cumulating double bond with different groups on periphery, it's called axial chirality, and alkenes with odd number of cumulative double bond, that means this type of things, odd number of double bond where the molecule become planars, that can be determined as a cis trans isomerism. They are not classified as axial chirality system. Now there are certain compounds, not only alene, that shows the axial chirality, that means they possess a chiral axis. That is this type of allenes. Okay, this type of allenes are the AB system, AB, AB. Like in each periphery, there is a different groups present, but this particular group can be actually present here also. Okay, and this type of allenes are called ABCD type of system. Like all the four substituent in the each center, C, and this is, I don't know why it happened, and D. So this is called the ABCD type of allene system, where the four group are different and it possesses the axial chirality. Also, the spiro compounds and exocyclic double bonds also shown active chirality, and the biphenyl compound, that means the already we discussed about atropisomerism. So this type of biphenyl system also shown axial chirality. So in this particular lecture, we are talking about axial chirality, cumulative system, atropisomerism, planar chirality, and helical chirality. So in the next particular lecture, this is our lecture 10, we are discussing about the RS nomenclature of chiral axis compound, like how can I determine the RS nomenclature of the molecule which contains chiral axis. So we are ending this lecture here, and thank you for listening.